Hello, welcome everybody to the second installment of our series of Fireside chats on the topic of leadership in AI and data science. This series is organized by the data science section of the Royal Statistical Society. If you don't know already, we are the membership group representing data scientists in the UK. We have over 3,000 members, and our aim is to support the career development of data scientists and AI specialists in the UK, foster good practice for professional data scientists, and provide the voice of the practitioner to policymakers. So please join us by signing up on our website, datasciencesection.org. We'll also be providing a link in the chat. And during the event, please use the Zoom QA function to add your questions to the discussion. And also note that we will be filming this session. Now I will hand over to Giles Pavey, who is the Global Director of Data Science at Unilever, and more importantly, a member of our organizing committee.
Thanks, Martin. Welcome to this Fireside chat, the second in our series. And I'm delighted today to be speaking to Anthony Goldbloom. Today's format is a 45-minute web talk with 30 minutes of chat with Anthony, followed by an opportunity for Q&A. Please post any questions as we go along into the Q&A box, and we will endeavour to ask them of Anthony as we go. So let me introduce Anthony to you. Anthony is the founder and CEO of Kaggle, which is now a Google company, the world's largest data science and machine learning community, with over 6 million members, I believe. Forbes has twice named Anthony as one of the 30 under 30 in technology, and MIT Technology Review has named him as one of the 35 innovators under 35. And the University of Melbourne has given Anthony an Alumni of Distinction Award. So welcome to you, Anthony.
Thanks very much.
I'd love to kick off by, if you could tell us what led you to start Kaggle.
Yeah, sure. So my background is econometrics and statistics. So perhaps similar to the background of quite a few people in your membership. So my first job out of college, I worked at the Australian Treasury forecasting GDP, inflation, unemployment. My second job was at the Reserve Bank of Australia, so the equivalent of, I guess, Her Majesty's Treasury and then the Bank of England. The way I tell the story, a couple of things in 2017, I won a journalism internship to The Economist magazine, and one of the stories I wrote was this emerging, or did a lot of research for, was this emerging concept of what was then called data mining, and became really, pretty fascinated. I spoke to, I don't think it was you, Giles, but I spoke to somebody at dunnhumby early on and found a lot of the work being done there very interesting. And I came back sort of really interested in the idea of the statistical techniques that I was applying to forecasting, GDP, inflation, and unemployment, but applied to business. And had seen, I think there was a prominent data science machine learning competition called the KDD Cup. And how it worked was, if you were, and that's a, KDD, just to explain, KDD is a conference, an applied, data mining machine learning conference. And you could get to speak at the conference by submitting a normal peer review paper, or they also had another track where if you did well in the competition, you got to present the results on the challenge that you had done well in. I always thought that was a really elegant way to decide, who had algorithms that were particularly strong. And so I was very interested in bringing that idea that I had seen working in academia into industry. And so that's initially where Kaggle started. And so after my internship at The Economist, where I'd been exposed to data mining and learned about the KDD Cup, I went back to my job as a statistician in Australia, but had this sort of burning interest to build a KDD Cup for industry, and that's where Kaggle started.
And this was back in 2011, around that time, is that right?
Yeah, Kaggle. I started working on Kaggle in 2009. and launched in actually would have been a little over 11 years ago in 2010. And the reason I know it's just a little over 11 years ago is the first competition we ran was to predict the voting matrix for the Eurovision Song Contest. And of course, as you'll all know, being in the UK, it's Eurovision week this week. So my first competition must have been ending around now. So yeah, this is, I guess, so Eurovision week is always a bit of a moment of reflection with respect to Kaggle, because it played an important early role in getting the community off the ground.
That's fantastic. So you've been going for 10 years. I imagine there must be so many changes, but can you talk us through what have been the biggest changes over that period of being right in the heart of data science, I guess?
Yeah, there's certainly been a lot. First of all, the word data science didn't exist at the time. And one of the first accomplishments, I think, that Kaggle, from Kaggle was bringing together all these disparate disciplines. You had statisticians and econometricians and bioinformaticians, and really we're all trying to do fairly similar things, but we're using very different tools and have very different methods. And what Kaggle, one of the early achievements was just bringing all these people together and having the different techniques go head to head with each other. And so one of the first realizations that came out of Kaggle was that, people used, in the early competitions, people used, the various GLM models. They would use support vector machines if they came from a computer science background. They might use self-organizing maps, all sorts of different techniques. It became very clear very quickly that random forest was the dominant strategy for winning the early competitions, the combination of clever feature engineering and random forest. I think, thanks to Kaggle, that technique really spread out to all those different sub-disciplines. Then I'd say the word data science really started to come to prominence around 2012, and that was following on O'Reilly, the book publisher, hosted a conference called Strata that brought a lot of those people who had that background together under the same roof. And I think that's where the term data science maybe initially was being used at Facebook and LinkedIn in the early days of those companies to define this skill. But I think the Strata conference in 2012 started to spread the term and have it become more widely used. And I think that was really useful for having all these people who had roughly the same skill set identify under a single type of profession. Then maybe I'll go through one more very large breakthrough that has happened over Kaggle's lifetime, which was in 2012. We had the AlexNet breakthrough. So that was the beginning of deep learning. And so deep learning did very well initially on ImageNet. And then a fun story, Jeff Hinton and George Dahl, not long after their ImageNet results, won a Kaggle competition. This is a competition for Merck to predict which chemical compounds would make for good drugs and which ones wouldn't. And so the combination of ImageNet, then following on from that, the strong Kaggle result made people in the Kaggle community very, very interested in neural networks. And the competition immediately after the Merck competition was run by, actually, I think it was a British company called Adzuna. They were trying to predict, take the text of a job ad and predict what the salary would be or something like that. And that competition was won by Vlad Min, who was one of Hinton's grad students, now a well-regarded researcher at DeepMind. And so that started to see a drumbeat of results using deep learning. Firstly, the early competition winners were all out of that University of Toronto lab, but it was exciting to start to see deep learning spread to be used by more and more of the community. And big breakthroughs or big developments like Francois Chollet introducing Keras into the Kaggle community made deep learning much more accessible, and to the point where it's now winning a higher and higher fraction of competitions.
Fantastic. So, and has there been a noticeable change in, I don't know, like the types of people who've joined the community in any way, geography or background, or what they're looking for?
I mean, very, very early on, the Kaggle community over-indexed on Australia. I think because I was Australian and started in Australia. That quickly faded, and today I think we see North America and India as the two large population bases for the Kaggle community. We have a tremendous amount of very, very, very strong data scientists coming out of Eastern Europe. So places like Russia, the Ukraine, places like that. You know, if you look at the top 100 or so, you see a disproportionate representation from Eastern Europe. You know, one thing Kaggle has been trying to, we feel a responsibility to try and get more diversity into data science. We have a leveraged role to play there, and I would say for 3 years in a row, the proportion of females in the Kaggle community was stuck at around 16%, and in the last year that started to rise, and we're up to about 22%. So that's another big focus, and we have quite a few female grandmasters who have become very prominent, who I think are really great role models to show what's, you know, to make it clear that Kaggle is a pretty friendly place to be for, you know, different genders, different backgrounds. So that's been a nice dynamic that we started to see more recently.
Fantastic. And in terms of, I guess, over those years, seeing people do well in competitions, would you say that do you have any insights into you know, how people seem to do well? I don't know, what approach they take? Is it to do with the modeling, or is it deeper than that, or wider?
I'm going to give you a generic answer, and then we'll zero in on a couple of the different problem types. The generic answer is one of the most rewarding parts of Kaggle is to see people enter the community really as fairly new to data science. You know, I think to do well, you should have some basic statistical background, the ability to code in Python. I don't think you don't need to be as good at stats as you probably think you need to be. You don't need to be as good a programmer as you think you need to be. But if you have a little bit of statistics and a little bit of programming, then you know, if you are of the learning by doing type of profile, it's an amazing way to learn. You know, some people learn well by watching YouTube lectures or you know, reading textbooks. Some people do better by learning by doing, and I think the learning by doing type does extremely well on Kaggle. The number one characteristic from people who do well is, or who come to do well, is tenacity. So you start off and maybe you finish your first competition in the bottom 20%, and then the next competition you're in the bottom 30%, and then the bottom 40%. But continuing to try and to read the winners post and see what they did and understand as much of it as you possibly can, and try some of the simpler techniques you see the winners doing in the next competition you compete in, is a really you'll be amazed at the rate of improvement. I remember one of the early grandmasters used to say, for any competition, he would make sure that he just submitted one entry per day. And so let's say it was a binary prediction problem predicting true or false. You know, day number one, he might pick all true. Then day number two, he might you know, build a basic model with one feature, you know, if this, then this. Then day number three, you know, each day come back and try and, you know, don't spend hours and hours a day on a competition, but each day, you know, maybe the first day you sort of set up your architecture for submitting, and then each day try and get some improvement in. And the rate, if you take that approach where you make these bite-sized improvements every day, you know, fabulous way to learn and improve. Then a couple of other characteristics. I said some statistical ability. That really the main thing that you need to check for is that you're not overfitting to the public data leaderboard. So when you compete in a Kaggle competition, you know, you build a solution, then you submit it, and then you see your performance on a live leaderboard, how you're doing relative to others. And it's very tempting to just try and improve the public leaderboard score. But very often what you'll be doing is you'll be overfitting to the public leaderboard. And in the end of a competition, what we do is we throw away that test data set and we retest you on a second, we retest you on a second test data set. And so overfitting to the public leaderboard is a very common trap for people new to Kaggle. And so you want to be doing techniques like cross-validation, making sure that in your cross-validation splits that your results are lining up with what you see on the public leaderboard, and building algorithms that are robust to cross-validation. And then finally, once you get past your tenacity and you're trying something new every day, once you get to the point where you're checking for overfitting, the final piece to actually win competitions is creativity. You can't just apply the same recipes that everybody else is applying. You have to find something that others aren't doing, that some insight you have that others aren't doing. Maybe to give you some examples for structured data challenges, very often that means finding a feature that others didn't think of. So the example I always give, it's quite an old example now, is we hosted a competition to predict which cars sold at a secondhand auction would be good buys and which would be lemons. And it turned out one of the best predictors was car color. It turned out if you had an unusual color car, it was more likely to be reliable because the original buyers of unusual color cars were more likely to be enthusiasts, was the hypothesis that the person had, right? And how did he find that? Well, he came up with many, many hypotheses. Dark color cars versus light color cars was another transformation he made on the assumption that dark color cars get into accidents more at night. Well, that didn't have any relationship, but he just came up with lots and lots and lots of hypotheses, tested them rigorously and kept the very small number that actually worked. For the neural network competitions, or the computer vision and speech, there's a lot of different ways that creativity can come into play. I remember we hosted a competition to figure out to order satellite images. So you're given a whole lot of satellite images, and you had to figure out what order they were in. And people did all sorts of clever things, like that identify a construction site in the satellite image, and that do image recognition on the construction site to figure out the percentage completed, right? Because the construction goes, you get more and more and more construction each day. So clever creative tricks like that really tend to be the difference between doing okay in a competition and building a serviceable algorithm and ultimately winning, if that's your goal.
Yeah, that actually brings me on to my next question, which is, I guess, given your experience at Kaggle, I mean, what does that show us, I guess, about the relationships between how humans and computers work best together, and how you think that might continue to develop?
Yeah, totally. I mean, it's definitely the case that the things that tend to be the difference between a very strong algorithm and an algorithm that isn't so strong are things that are hard for a computer to do, right? You're trying to do something creative, and by construction, something creative is something that is out of the box, that isn't isn't something that you could train an algorithm necessarily to do. But once you have that. But then, yeah, so I think the computers are very good at taking a problem that you structure nicely, giving obviously a training example that you're trying to target, and figuring out the weights or the parameters of the model. We can't doing that by hand would be beyond laborious. But we're very good at coming up with creative ways to frame the problem, creative features to put into the model. That's how I look at where not a blistering insight, but where humans shine and where machines shine.
And we're seeing the rise or more and more sort of AutoML, which is, just give me the data and I'll magically spit out the best model. Is there any evidence from Kaggle that those are gaining ground on the sort of human and computer competition?
Yeah, I mean, still, we're not seeing AutoML. Seeing AutoML. I've actually competed in a competition myself using AutoML. I was curious to see it, to your question, like, how well does a mediocre data scientist like me do with the power of something like AutoML? And the answer is decently well, but not exceptional. The clever tricks that a lot of the top performers, like, I think an AutoML solution will consistently get you. Sorry, an AutoML solution where you have set up the problem nicely, I think can consistently get you let's say top 10% finish. And that probably is sufficient for a lot of problems. I'm quite excited about AutoML and AutoML-based solutions. And the reason being is I don't think it is a great use of a human being's creativity, et cetera, to be setting learning rates and even picking architectures potentially. I think it's a much better use of a human's time to be figuring out, what features do I put into the model? What data augmentation, forgetting the standard data augmentation, but what creative data augmentation do I want to add into this model? What data augmentation do I want to avoid for this model? So I think that the place where the human should spend the time is setting up the problem, thinking about the data to feed into the model, and then the tuning of learning rates and things like that. I'm pretty excited for a day when we have AutoML-based solutions that are just taking care of all of that, knob turning without us needing to do it.
Very good. So a bit of a change of tack. So a few years back now, you were acquired by Google. And I'm sure lots of us are interested to just hear, what's that been like? What are the pros and, dare I say it, the cons of that process? And how do you find yourself now?
Yeah, sure. I mean, Kaggle is probably in a fairly unusual situation for an acquired company in that we continue to run under our own brand and with a fairly autonomous team. So, I'm still the CEO. The Kaggle team reports up to me, which is a little bit different from how other Google teams tend to report. The pros are there are a bunch of pros. One of them is we hire out of, very often other people from other Google teams transfer onto our team, and the caliber of Google engine, I feel like pre-acquisition, I used to spend somewhere in the range of 30 to 40 of my % of my time trying to hire really strong engineers. And that has gone down to about 1 to 2% of my time. So that's a massive pro. Secondly, I think Google, one really nice thing is we line up with a report into Google Cloud, and it's been nice to be able to give our community access to far more compute than we could offer as a standalone company, as well as different techniques and technologies. So you can use TPUs, for instance, which is Google's. The GPUs and TPUs are two different types of accelerators. We offered neither through our hosted notebook product before we were acquired by Google. Now we offer both. And so it's given our community exposure to really nice technologies like GPUs and TPUs. We actually do have a very nice integration with Google's AutoML solution, which is the one I use to get my top 10% performance relatively recently. Kaggle notebooks have a limited amount of compute, but if you run out of compute with our notebooks, you can escape to GCP's notebook product, which has a fair bit more obviously power available to you. So I think that it's been a big win for the community. I think the way we organize the acquisition is we wouldn't suppress anything that anyone did on Kaggle, preferring Google technologies over non-Google technologies. But if Google has a technology that can lift up what people in the community are doing, we would make it available to our community. And so I think from the community's perspective, it's been a one-way bet. On the challenging side, I think just learning to operate effectively in a large company. There's many more stakeholders, and whereas I used to spend 30 to 40% of my time on engineering recruiting, some portion of that now has gone towards stakeholder management. Keeping other teams updated with what Kaggle's focused on, making sure that what we're focused on lines up with priorities in other parts of Google Cloud and that sort of thing. So not so much a total for me, I guess, as Kaggle CEO, a new skill to learn, and something that in a startup you want to try out a new direction, you just go and do it. As part of a large company, you have to sort of get alignment before trying something new or pursuing something different.
One question that we've had come in was, what's kind of next for Kaggle? I'm a bit conscious that maybe not everybody on the call would be like completely aware of all the different things that happen on Kaggle. Maybe the competitions are, speaking personally, I guess that's how I was introduced, and that's kind of what I associate Kaggle with. But what are the range of things that you're doing, and what are the next things for you guys?
Totally. So maybe to walk back and describe, how Kaggle started, and then how we have grown over time, and then I will parlay that into what's next. So Kaggle started off, as I guess is probably hinted at where most of this conversation has been around, is with machine learning competitions. And how this works is a company will post a problem, and people in our community compete to build the most accurate algorithm, and the winners win prize money. And in exchange, they give the code to the company that hosted the competition. In around about 2015, so that's launched in 2010 and was really Kaggle's primary product between 2010 and 2015. In around 2015, the community is really starting to grow. Competitions were at a point of maturity where we thought we could start to look at investing in other things. And the way we have decided to grow and expand Kaggle is to look at what people are trying to do in the community and struggling with. And one thing we noticed the community was trying to do was to share code. And what they would do is share, take a Python file and attach it in our forums. That's a very clunky way to share Python code, because someone would share code. In order for another community member to run it, they'd need the same version of Python, the same libraries, potentially the same versions of those libraries. And so to get somebody's Python script working, it might take you 2 to 4 hours. And so in a lot of cases, people weren't really downloading and using each other's code. And so we built into Kaggle what's now kind of like a hosted Jupyter notebook, for those of you who know Jupyter notebooks. So today, if you open up a Jupyter notebook, that is local on your local machine. If you come to Kaggle, you have a version of Jupyter notebook that runs on our servers. And so you can think of it a little bit like if you used to use Microsoft Word locally, what it's like to use Google Docs by comparison. It's in the cloud and you can collaborate nicely and so forth. So that was the second product we launched. Then when we launched the hosted notebook, our purpose in launching it was to support code sharing for the purposes of competitions, to replace code sharing in the forums. But we noticed people starting to use our notebooks on things beyond competitions. And that led us to want to give our community more data sets to be able to play with, not just, we had the competition data sets, but those are limited to, let's say we'd launch 5 competitions a month or something like that. I mean, you only ever had 5 data sets that we could provide you that you could use in the notebooks. So we launched a public data platform where basically anybody in our community can upload any data set. So we now have a collection of around about 85,000 data sets on Kaggle that have been shared. These data sets are, you can download them, and there's probably a data set on any topic you could imagine. This is now actually surprisingly, given Kaggle's brand is so much around competitions, the largest and fastest growing part of Kaggle. And so it's an area we're looking to invest more in. A couple of the ideas that we're tossing around at the moment, one is firstly, we want to encourage our community and build the tooling that allows our community to keep those data sets updated. One drawback at the moment of the public data platform is a lot of those data sets are stale. And we'd like them, to be updated on a regular basis so that they're more useful to more people. The other kind of intriguing thing we're playing around with is this idea of allowing our community to become data entrepreneurs. So, one thing had always hoped would be true is that through competitions, we could offer economic opportunity to our community. In practice, what's happened is the number of competitions we launch grows at a much slower rate than the size of the community. The community is almost 7 million now, and there's just like a limit to how fast we can onboard competitions. And so I see this opportunity for our community to start maintaining data sets and potentially selling them through Kaggle as a way, as firstly a nice potential revenue stream for Kaggle, and also a way for our community to get economic opportunity. I should say this is an idea that's in the very, very early stages of something we're thinking about, but it's a direction I'm excited about.
We've had comments here about the fantastic contribution that Kaggle's made to the education of data scientists. And there's an interesting point here where what role do you see in the courses such as those offered by Kaggle versus, I guess, a more traditional academic degree?
Yeah. Sure. So the way we target our courses is they're supposed to be, we call them micro courses, and they're supposed to be as short as we can possibly make them, no longer than 4 hours. And the idea isn't to teach you everything there is to know about matrix multiplication and how neural networks are trained and so on and so forth, but to give you just enough so that you can go off and take on a project on Kaggle, whether it be compete in a competition, take a data set that interests you and write an interesting analysis on it. And so it's very much aimed at catering towards the learning by doing mindset. So if you want to become a machine learning researcher, and it's probably going to be very important for you to understand every bit of the matrix algebra that underpins a neural network. Certainly, I think early in your data science journey, if you're aiming to be more of an applied data scientist, I think starting with a lot of that stuff can be very intimidating. And the way I think about it is, if you take the learning by doing approach, you learn what you need when you need it. So you start off and you train a very basic neural network, and then you want to improve on that neural network, and you get stuck. And then you have to go in and you might have to understand a little bit more of the lower level of what's happening underneath the algorithm. But you dig into things like the mathematics underneath a neural network when you need it, as opposed to more of an academic setting where you're doing it, there's more academic rigor to it, but you're doing it as part of, maybe a lot of that stuff tends to be given to you earlier on. And so, my view is if you are of the learning by doing type, and you are focused on becoming a strong applied machine learner, Kaggle is a wonderful training ground. Actually, I have a really nice story that I want to share. That I can share this. It's been shared by the Kaggle data scientist. But he talks about he used to build algorithms to basically do debt collection. This is one of our strongest community members, and he learned through Kaggle, built up a really strong profile on Kaggle, started doing very well on Kaggle, and got hired by Lyft. Relatively junior in their autonomous vehicle team, and he joined this team and noticed a couple of senior researchers gave a seminar on a problem they were trying to address, and these were PhDs from very well-known universities, and they've been stuck on this problem for about 3 months. And he took that problem home and solved it over the weekend. And he said the reason he could solve that problem over the weekend is because he says Kaggle is like, muscle training for data scientists. You're so used to picking up a new problem, trying to get to a good answer really quickly, iterating very quickly on many different data sets, that you can often pick up a new data set and get to a very good answer very quickly. And that is something that the PhDs from the more elite universities had been noodling on this problem for 3 months. He could take it home over the weekend and make a lot of progress. And so he became very well regarded and so forth in the Lyft autonomous vehicle team as a result of very quickly being able to unblock a very thorny problem. And I think that's really what Kaggle, it's ultimately what a lot of time spent on Kaggle teaches.
Very good. We've got a question here from Ashwin. Anthony, you commented on there being more women taking part in Kaggle competitions recently. This is really encouraging. Could you speak to how Kaggle stimulates this growth and how Kaggle hopes to continue to increase diversity in data science as a whole?
Yeah, we have what's called a diversity working group on our team that's focused on different initiatives in order to bolster participation of females, specifically females on Kaggle. The target is that we've been stuck at 16% for a while. I think the goal is that by the end of 2022, we want to be at 30%, and we're making nice progress towards that goal. There's been a bunch of things that we've tried to do consciously to achieve that goal. First of all, we started off with a research project, trying to understand to the extent that, what are the big blockers to more female participation on Kaggle. And one of the biggest ones was just a lack of role models, a lack of seeing others who had done well. We do have a bunch of Kaggle grandmasters, female Kaggle grandmasters, and I think we've made a big effort to make them a bit more prominent on Kaggle, as well as within our team. We had them come and speak to our team and have our team learn more about their experience and so forth. So that has been a major push. We've done a little bit of work with some groups like the WIDS Women in Data Science group, running competitions with them. These are a couple of things that are top of mind, but I think based on what we've learned, based on the research we've done and some of our early experience, I think the best thing we can do is highlight, the fact that we do have this. Kaggle is a friendly place for females, and we do have some females doing exceptionally well on Kaggle and making sure they're as visible as can be. Very
good. Mindful of the time, we've probably got about 5-10 minutes left, so let's keep going. We've got plenty of questions here. What types of competitions would you like to see more of, and which industries would you like to see more engaging with Kaggle?
It's a good question. I personally always get excited by competitions at the intersection of science and data science, hard science and data science. One of the ones we've done recently that really lights up for me is we did a competition with a well-known biochemist at Stanford to take some of the RNA vaccine designs that people are designing for COVID-19 and trying to predict how stable they would be. So the stability, RNA's vaccines are famously not very stable. It's why you have to store them in ultra cold temperatures, etc. And so if you can design our mRNA vaccines that are more stable, then they degrade less quickly, and you don't have to keep them in ultra cold temperatures, etc. So I absolutely love that competition, both because it was at the intersect. It touched on a problem that at the time was very pertinent and needed. Obviously had a lot of potential consequence for vaccine design, which is something that a lot of us obviously are paying a lot of attention to, as well as just personally liking competitions that operate at the intersection of hard science and data science. I think pulling, those are the kinds of competitions I like. Pulling back, I think one complaint we often get from the community is that we over-index a little bit on computer vision problems. A lot of the exciting work at the moment is happening in natural language processing, natural language processing as it intersects with speech recognition. I think there's a lot interesting around recommender systems at the moment, ranking and recommender systems. And so I think from the sake of giving the community what the community wants, I'd like us to be able to offer a more balanced set of competitions that mean that regardless of what what domain you're interested in or interested to dig in on, we have a compelling problem for you at any point in time. One thing that we struggle with is we don't come up with the competitions ourselves, but rather companies bring them to us. And we much prefer that because there's something different about working on a competition that we manufacture versus a competition that somebody really cares about, that is real to somebody. And it's hard to replicate that authenticity. And so that's why we have tended not to engineer our own competitions in areas where we don't have such a good representation. One thing we do, and it's another nice benefit of being at Google, is in any of these domains, there are many Google teams doing research and building models in these areas. And so we do sometimes reach out to Google teams that may have some interesting problems in a domain that we think has been a little underrepresented on Kaggle.
Very good. Here's a specific question, but I think it'll be interesting to a good section of our audience. So what advice would you give to a public sector, so government, whatever, organisation looking to host Kaggle competitions in the UK, I guess, anyway?
Yeah, I mean, we've done quite a few. I know we've done competitions with DSTL. They come to mind immediately. I can't help but feel like there have been other public sector in the UK that we've run competitions with. But reach out to us. I think the thing that we need is we need you to have a large enough data set. We need you to have labels or a target variable that's not out there in the public already. But large enough, I should say, is often as small as 2,000 rows. It doesn't have to be ginormous. And in fact, I think a lot of the interesting work to be done in machine learning is to be able to come up with good models on smaller data sets. Yeah, you can, I don't know if my details will be circulated after this, but my email is a@kaggle.com. So if you have a competition you'd like to run, I can route you to the right team.
Excellent.
The right person on our team.
One question that's come up in a few different forms, and I guess you'd have an interesting perspective on. So you're in the heart, I think, 6 million members, something like that, over those 10 years. And I'm pretty sure for all of those 10 years, there would have been discussion in wider circles about a skills gap for data scientists. What's your thought on whether there's still a skills gap and how that can be closed? Yeah,
I would say 4 or 5 years ago, when I would speak to companies, the thing I heard more than anything is, great, I want to hire data scientists, but how on earth do I get one? I hear about that less than I did 4 or 5 years ago. That's not to say, I still think it's an incredibly rewarding profession. I think the skills gap is not nearly as acute as it was. Kaggle's community 4 years ago was around about 840,000. Now we're getting close to 7 million. That being said, the fact that the skills gap is not as acute as it was is not at all to be discouraging to those who are entering the field now. I think there's still a tremendous amount of demand. And also it's an incredibly rewarding career. I believe that there's nothing more exciting than sinking your teeth, in my view, and hopefully the view of people who attend a Royal Statistical Society talk. Every data set has its secrets, right? And I find it really fun to dig in and to understand, to try and pull out, what knowledge is encapsulated in a data set. So just because, the skills gap, I think, is not as acute as it was, but still an incredibly rewarding and in all ways career direction, in my view.
Excellent. Right. Well, I'll just try and squeeze in a couple more. So maybe a couple of quick fire ones. You talked about Python. Is Python still the predominant tool of choice? Do you see anything on the rise?
Yeah, Python is, if anything, becoming more dominant. at least on Kaggle, I know there is a thriving R community, and it is R was very popular in Kaggle. In the early days, it used to dominate. It's certainly declined relative to Python, and I think the library support in Python is stronger. That being said, talk about in tech an area where that has really excelled in terms of diversity. I think you'll find that the R community is considered to be very welcoming and a particularly diverse community, and it's one of the big strengths. It's hard for me to make an assessment. I think if you're doing data exploration and plotting and so forth, R is a wonderful option. If you're doing more machine learning type work, I think Python is stronger. We've for a while been excited about Julia. There are things to be excited about there, but it still continues to be the language that is promising to be the next big language, but hasn't quite matured to the point where it has the library support to make it a really strong option. And then there has been some excitement around other things like Swift and things like that, but nothing really that is. I think Python is still the right bet to make. Okay,
and here's a personal. So we're hearing more and more about the need for explainability in AI. I could be wrong, but it seems like Kaggle is maybe the ultimate. You don't have to explain it kind of area. But is that something that you're seeing a sort of rise in, or in any way involved in, or thinking about?
Totally. I mean, actually, even on Kaggle, it's not something that is judged in Kaggle competitions. But at the end of a Kaggle competition, the winner shares their code, documentation, and a presentation with the winners, and with the competition host, and explaining how their model works is really the main component of those screen share presentations and the documentation. Nobody is going to put a model into production without understanding what's driving model performance. So I think it's explainability is I wish there were ways that Kaggle could could judge a competition that including explainability criteria. We haven't found a neat way to do that, but it is something that certainly when we deliver algorithms that our customers care about.
Fantastic stuff. Well, here's a cheeky one to maybe end with, Anthony. So in the introduction, we heard about how you are one of the 30 under 30 to watch, and then you became one of the 35 under 35. I'm kind of guesstimating what your age is, but which list do you want to be when you're one of the 40? Are you targeting anywhere?
No, I'm 37. I think it's harder to be a 40 under 40 than the older the category gets, the harder it is, I think.
Surely there's more of them.
But I also think maybe the being philosophical, the older I get, the less I care. I get my rewards from things like meeting Kaggle community members whose lives we've touched. I find very rewarding, and ultimately, I want to look back on a career where I feel like I've done useful and productive things. And so I think that, to be honest, is where I used to like sharing accolades, et cetera, with my parents. And I think now I'm looking for fulfillment. Yeah, I guess fulfillment from more from in other places.
Fantastic stuff. Well, look, I think we're at the end of our time. I know you've got places that you need to be, because it's obviously still early. You're in San Francisco, is that right?
Yeah.
Just finally, any closing remarks you'd like to make?
No, thank you very much. I was very, very honoured to speak at such an august, grouping as the Royal Statistical Society, and to follow up from Andrew Ng. So flattered to be asked and enjoyed the opportunity. Thank you for the great questions.
Thank you. Well, thank you again for that, which will make our highlights reel as well. So thank you ever so much, Anthony. You've been a fantastic guest for us this evening, and I'm sure that that not only of those who are able to join today, gain from your insights, but it'll be something that we'll also make available on the RSS YouTube channel for others to share in. So thank you very much. I think all that remains for me to say is that for those of you who are on the RSS Data Science section mailing list, please do join up. You can find that online or in the chat. We'll be running more events coming through. We're at the RSS conference. We're also looking to do work on that we can feed into the government about the view from the data science community of practitioners. So stay tuned for that. And with that, I'll say thank you once again to Anthony, and good night and have a good evening to everybody on the call. Thank you very much.